Next, a field. What is a field? A field is a quantity everywhere in a region. Field can be either scalar or vector. Let's see example. Temperature distribution in a building. Is it scalar or vector? For temperature, we don't have the direction. It's just a magnitude. How hot the surrounding is. So, this is a scalar unit. And then the gravitational force on a body in a space. As we know, okay, the gravitational force always directed towards the Earth. Okay, let's say we have one object, and then the gravitational force always going down towards the Earth, F. So, this one, the gravitational force has the magnitude, okay, which is a MA, and also the directions. Okay, it has directions. Maybe going down. I can write as here. This is actually a vector unit. Well, when you understand about the vectors, next, what we can do between maybe two vectors? Can we do the additional, subtractions, or multiplications? And what is the properties of that thing? Alright, we see. Let's say we have two vector, which is A. Okay, vector A, the blue colors. Okay, this is the directions. And then we have the vector B going in these directions. Okay, we want to do additions, subtraction, and also multiplication between these two vectors. Let's say first the vector additions. Okay, we see back, this is the directions. Okay, what happens if we want to add together? Okay, so this is the direction of vector A, and we add with a vector B. These directions. So we will obtain the vector C from this point to this point, where the vector C is equal to A plus B. Okay, or we can write as this this form, where the vector C is basically equal to the vector B plus vector A. Okay, we solve the B first, and we plus the A, and then you can see that it will form the same vector C, the same direction, the same magnitude. So we can say that the A plus B is equal to B plus A. This is a first behavior for vector additions. Next, for vector subtractions, okay, the same vectors. I want to subtract A minus B. Here, A minus B is basically we just reverse the direction of B. We know that B in these directions. When we reverse the directions, so it becomes minus B. So this is a subtractions. Let's say the vector is here in these directions. So A, actually A plus minus B. A minus B is equal to A plus minus B. Right? This is how we write the vector subtractions. Next is a vector multiplications. First, the multiplication with a scalar. Next is a dot product. And lastly, the cross product. What is the difference between that? For example, the first case, multiplication with scalar or a constant, k. Let's say I want to multiply k. K is a value with the vector a. So, if a is equal to xax plus yay plus zaz, so basically, if we want to multiply k, so we can just multiply for each component. Okay, or we can simplify the form into this form. So A is the magnitude, the total magnitude of AX, AY, AZ, and then A here is the unit vector, where the A here is combination of unit vector X, unit vector Y, and unit vector Z. Okay. Next, the vector analysis for dot product. Okay, for dot product, when the unit vector is the same, so the dot product between the two unit vector, you will have 1 here. For the different unit vector, it becomes 0. So please remember this behavior. Let's say you have a vector A and B. How to do the dot product between these two vectors? So the dot product between two vectors A and B is equal to AB cos theta AB. AB cos theta AB, where the AB is the smallest angle between vectors. That means the dot product, we should multiply two vector which is parallel. The vector must be parallel. So we have to change the B here into these directions. Basically, you can solve by using the concept of trigonometry. Let's say this is a 90 degrees. Okay, this is I just rename as a A. This is a B, and this is C. Okay, so we can write as a cos theta AB is equal to, in refer to this diagram, is equal to B divided by C. And we want to know what is a B, because B is a parallel with vector A. So B is equal to C cos theta AB. This is the form. That's why you got this form. Okay. And then the properties of dot product. First, commutative. Okay, we can solve whether A dot product with B and or B dot product with A. It will give you the same answers, the same solutions. And another thing is, the result of dot product between two vector will give you a scalar unit. Okay, for example, A dot B, B dot A, you got one scalar unit. Okay, please remember this. Don't confuse. Next is the properties of distributive. Let's say you have vector A dot product with a B plus C. So this thing is equal to basically A dot B plus A dot C. It will be the same. Next, the cross product. Okay, the dot product and cross product is different. For the cross product, okay, let's say we have a vector A and B, where A may be in the direction of x-axis, okay, x-axis, and then B in the direction of y-axis. So the cross product between vector A and B is equal to n. N is basically the vector normal. Vector normal to the surface bounded by the vector A and B. Let's say this A cross B, this is a surface, and this is normal vectors. Okay, the normal vector n. So this is basically in the direction of z. So it's equal to n a b sine theta a b. That means the result of cross product between two vectors will give another vector, where the vector is perpendicular between the vector A and B. It's always perpendicular. So the cross product is important for a magnetostatic field. Okay, please remember, for dot product is important for electrostatic field. Okay, that's all for the first part. Next is the behavior of a vector product, the cross product. Okay, previously we see that the dot product between the vector A in vector B is equal to the vector B dot product with vector A. But remember, for cross products, it is different. Okay, A cross B is equal to minus B cross A. Is equal to minus B cross A. But the distributive behavior is still the same. A cross B plus C is equal to A cross B plus A cross C. Okay, normally I will draw this diagram to make sure that you will not making any mistake. For example, I have in Cartesian coordinate, I have X, Y, and Z. And this is the direction of a cross product. So let's say I have a vectors in X directions. I want to cross product with a Y component. So the result we will have in a Z component if you follow this sequence. But if we follow the other sequence, so the result will be negative. So just depend on what kind of vector that you deal. Okay, next is about the unit vector. What is the result of unit vector between the y cross x, z cross z? This is what I mentioned here. Okay, let's say I draw again. Here, let's say we have y cross x. Y cross x is in these sections. Okay, it's other sequence. So the result should be in negative z. And then what happens if z cross z? The same vector. If the same vector for cross product, the result will be 0. Okay, that's all for the first part.